In the first video of this module, we'll be looking at developing a model of a simple healthcare clinic. And in our healthcare clinic, we have the following stations, offices, machines, however you want to think about it. There's a registration location where patients come in and register within the clinic, triage where patients are evaluated, treatment room or office where patients are treated, laboratory service where they go and have blood work, etc., an X-ray, an MRI, an EKG, and an accounting office where people go to pay and deal with the insurance matters. And so we're also going to have several different patient types. So we'll have walk-in patients that walk in for some type of treatment. We have lab-only patients who come to have blood work done, for example. There are X-ray patients, MRI patients, and EKG patients. And so we have these different categories of patients that come through our clinic. So for some additional detail, what we're interested in is looking at the patient routing sequence. So in other words, which stations do the patients go through by type, by patient type. So for example, what this table shows is that walk-in patients first register, go to triage, treatment, and then accounting. So they don't do lab, X-ray, MRI, or EKG. We're going to just assume that walk-in patients just go through some triage and treatment before departing. Lab-only patients don't have to register because it's such a frequent occurrence that the lab has its own registration process. So lab-only patients go directly to the lab and accounting. X-ray comes to registration, then X-ray, then accounting. Similarly, MRI and EKG both register first, then go to their respective station, and then go to accounting. And so that's what we'd like to do is develop a model of this facility, and we have some parameters that we'll talk about, and the performance metrics that we're interested in, initially at least, are just the typical queuing metrics that we've looked at many times, that are the utilizations of the servers, the waiting time and time in system of the patients, and the number of patients that are in the system at any given time. For the problem parameters and the initial verification model, I'm going to use this Excel model that I developed. And so what this model shows is the arrival rate in patients per hour for each one of the stations. And so for example, what the row 4 shows is for walk-in patients, there's a general arrival rate to the clinic of 10 per hour. And since walk-in patients go from to registration, triage, treatment, accounting, each corresponding station has a patient arrival rate of 10, 10, 10, and 10 corresponding to walk-in patients. Similarly, lab-only patients arrive to the clinic at the rate of 20 per hour, and since they only go to the lab and then to accounting, the lab has an arrival rate of lab patients of 20 per hour, and accounting also 20 per hour. And so for our initial model, we're also going to assume that the processing times at the stations are independent of patient type. And so in minutes, it takes approximately 2 minutes for a patient to register, regardless of whether they're walk-in, X-ray, MRI, or EKG. Treatment takes approximately 10.5 minutes. Accounting takes approximately 5 minutes, regardless of patient type. And we also have capacity of each one of our stations. So we have one registration clerk, one triage clinician, 2 treatment clinicians, and so on. And so given the arrival rate and the processing times, we can apply our standard static model that we have done before, and so we can just sum each one of the columns here, and so we have a total arrival rate to our system of 43. Registration sees a total arrival rate of 23 per hour, triage 10, and so on. And by applying our processing times, we can solve for the processing rate per hour given the process times and the capacity, and so then we can get the expected utilization at steady state by dividing the arrival rate by the processing rate. Note that in this spreadsheet, I've accounted for the capacity of the server in the processing rate calculation. So for example, when I have 4 when I have 4 accounting clerks, you can see that I computed the processing rate by taking 60 divided by the processing time and then multiplying that by the capacity to get 48. Note that if we assume the arrivals are Poisson and the processing times are exponential, and we use first in, first out queuing discipline, and you have infinite length queues, we could also use queuing analysis to solve for the expected number at each station and the expected time that patients spend in the system, but we're not going to do that for this example. So let's take a look at building the Simio model. And as the module name suggests, we're going to use a new idea called entity sequences to model the system. And so let's just sort of build the initial components of the model. So I'm going to first put down my stations. And so our system has several stations, so I'm going to just use multiplace and place our registration, triage, X-ray, MRI, treatment, lab, EKG, accounting, and then finally our sync where patients depart. And so I'm going to go in and rename these stations so I can keep track of them. So we'll name that one registration. We'll name our second one triage. We'll name our third one X-ray. We will name our fourth one MRI. Our fifth one will be treatment. Our sixth one will be the lab. 7 will be EKG. Last one finally will be accounting. So we have our stations now that correspond to our we have servers now that correspond to each one of our stations. So we have registration, triage, treatment, and so on. So now we need to create our individual patient types. And so let me zoom out a little bit and recall that we have patient types. Let me just pull these out here. We have walk-in, lab only, X-ray, MRI, and EKG. So let's name our entities. So we'll do let's do walk-in patient and lab patient, X-ray patients, MRI patients, and EKG patients. And I'm going to use symbol colors to differentiate between our different patient types. Of course, we could also use more colorful people symbols if we like, and you can do that if you like. I'm going to stick with the colors for now, and we'll talk about that alternative later in the module. So we have MRI, and then finally EKG. And so we now have walk-in patients, lab patients, X-ray patients, MRI patients, and EKG patients. And so we have separate arrival rates for each one of our patient types. So we are going to create a source of walk-in patients, a source for lab patients, a source for X-ray patients, source for MRI patients, and a source for EKG patients. So after I place the sources down, we need to make sure that we have the entity type set properly. So there's our source for walk-in patients, and then we'll choose lab patients for source 2, X-ray patients for source 3, MRI patients for source 4, and EKG patients for source 5. So let's make sure again we have walk-in patients, lab patients, X-ray patients, MRI patients, and EKG patients. And so we have this modeled, the separate arrival stream for each one of our patient types. And so now we have our servers down representing our stations, our sources and entity types that represent our different patients in the corresponding arrival stream, the next step is to put the entity routes in. And so recall that we have the different patient classes or different patient types, and they take different routes through the system. And so the complication comes, for example, if we look at the registration station. So if you're a walk-in patient, you go from registration to triage. If you're X-ray, you go from registration to X-ray. MRI goes from MRI to, from registration to MRI, and EKG goes from registration to EKG. So in our model, that would say that from the registration, so we're going to have several different several different entity types going to registration first, and when they come out of registration, the walk-in patients go to triage, the MRI patients go to MRI, the X-ray patients go to X-ray, and so on. So we'll have several alternatives emanating from many of the sources. And so the question is, how do we account for, or how do we implement those choices? Well, we could use selection weights, or we could use something like selection weights, but that would be fairly complicated, and it would also be difficult to add new patient types. So what we're going to look at in this module is something called entity sequences. And so what we will do with entity sequences is essentially define each row, walk-in, lab-only, X-ray, MRI, and EKG, as a sequence of station visits. So walk-in goes registration, triage, treatment, accounting, and then they exit. X-ray goes registration, X-ray, and then accounting, and then they exit. And so a sequence basically defines this visitation sequence in the model. And so to do that, we go to the Data tab, and in the Data tab, we're going to select sequence table. So across the top here, you can see I have add sequence table. So I'm going to add a sequence table, and I'm going to call my sequence table walk-in sequence, SEQ. And so the sequence table, if we look, just defines a sequence of nodes. And so the sequence of nodes for our walk-in patients, they go to registration first, followed by the triage, followed by treatment, followed by accounting, and then the input at the sink because they depart. And so we're looking at the input nodes for each one of the server objects. So go back to our facility, and that's saying when a walk-in patient arrives, they go from the source to the input at registration, which will lead them to go through the registration process. When they get to the output of registration, they go to the input of triage. Then they go from the output of triage to the input of treatment, and so on. And so the sequence again defines a sequence of node visitations for the entities. So let's define our other sequences. So we have a lab sequence, and the lab-only patients go directly to the lab because they don't have they don't have to go through the registration process. Then they go to accounting. Then they exit the system. The X-ray sequence, X-ray sequence, patients come to registration, then they go to X-ray, then they go to accounting, then they depart the system. The MRI sequence, they go from registration to MRI to accounting, and then they exit. And finally, the EKG. EKG patients come and arrive at registration. They go to the input at EKG, they go to accounting, and then they exit. So again, walk-in patients will go to registration, triage, treatment, accounting, and then depart. Lab patients will go lab, accounting, depart. X-ray patients go registration, X-ray, accounting, depart. MRI, registration, MRI, accounting, depart. and finally EKG. Go registration, EKG, accounting, and depart. So having defined our sequence table, the next step is to go back to the facility and define which sequence the individual model entity instances should follow. So I select walk-in patients, and I go to the properties and the routing logic, and there's a property called initial sequence. So we will select our walk-in sequence, then we'll go to lab patients and select the lab sequence. Then we go to X-ray patients and select the X-ray sequence, MRI patients and select the MRI sequence, and finally EKG and select the EKG sequence. So walk-in patients walk-in sequence, lab patients lab sequence, X-ray patients X-ray sequence, MRI patients MRI sequence, and EKG patients EKG sequence. And finally, to implement sequences, we need to now tell the individual transfer nodes to use the sequence to determine the route. So I'm going to select the output at source 1, and there is an option on the routing sequence that we've seen before called entity destination type, and by default this is continue. So I'm going to select that and change that to by sequence. And so the continue option says simply continue to your destination, and if you don't have a destination, then use the selection weights. But we don't want to do that. We want to use the entity sequence. So what we need to do is set that property for all of the transfer nodes. So I'm going to use multi-select and do those in mass. So I select the output node there, output node, output node, output node, then registration, triage, X-ray, lab, treatment, MRI, EKG, and accounting. So I have all of the output nodes except for the source 1, which I've already done, and I'm going to set the destination type to by sequence. And so now all of our nodes, if we just look at a couple randomly to make sure, have that property set so that when an entity departs, the Simio will look at that corresponding entity sequence to determine where the entity should go. So in summary, using sequences, we first define the sequence table. We then assign the sequence for the individual entities, and then we specify the sequence logic to use when entities depart each individual node. And so the next step that we would do is using the mechanisms that we've previously done, we would connect all of the objects, connect all of the stations together to facilitate entity flow. For this model, we're going to use something called free space travel. And in free space travel, entities essentially travel through free space. And so let's take a look at how to do that. First thing I'm going to do is I'm going to select all of the patients, and I'm going to initially slow down the patient. So I'm going to set all of their initial desired speed to 0.25 meters per second. We'll come back and revisit that in a second. And then I'm going to look at this initial network property, which we haven't looked at before. All entities are defined with a property of using the global network. We want to check that and select no network or free space. And so that's telling Simio that instead of traveling along a network, these entities should travel in free space. And so we do that, and now we click go, and we see the entities being created at the corresponding source and being transferred to their first station in their sequence, going through free space. So we have no paths, we have no time paths or connectors. Instead, the entities just travel from their source node, or from the output of the source node to the input of their destination, which is specified by the sequence. So before we go on, just a couple of words about free space travel. And so you can see, for example, EKG patients arrive and they go to the first step in their sequence registration. And what they do is Simio calculates the direct line of sight path from the output node to the destination or the input node. And so I can move these around, and Simio will recompute the paths that the entities should follow. And so in this case, it turns out to be a very convenient way, because we're not, at least for this version of the model, we're not particularly interested in the actual paths that they travel, but we're just looking at the station utilization and so on. So using free space travel in this case, it lets us eliminates the need for us to connect all of these up with either paths or time paths or connectors. So in the next video, we will then go in and add the parameters. Note that we haven't changed any of the arrival or service time parameters, and so we can see we already have a capacity problem at registration and at accounting, as we would expect that we would.